Okay, this is our second video looking at annuities. So we're still on exercise 7A. And in this video, we're going to have a look at what is the definition of an annuity, what is an annuity, and then we're going to connect annuities with recurrence relations, which we looked at last video. Okay, so the word annuity, whenever you see the word annuity, it refers to a financial situation involving regular fixed payments. And that's the key thing. Paid every period, every time period. So, for example, a regular fixed payment might be putting $1,000 into a savings account each year, or the same amount. It doesn't have to be $1,000. You could be putting $500 into a savings account every month, for example. Okay, as long as you've got a fixed amount for a fixed period. Okay, you're putting in a fixed amount repeatedly throughout that fixed period. Okay. So, look, there are a lot of practical applications of annuities in real life. For example, a mortgage, which is the same as a home loan. In a home loan situation, every month or every fortnight, you pay a certain amount. That amount stays fixed, and you pay it every fortnight or every month. Other types of loans, for example, car loans, are other examples of annuities. So we've got loans here as being examples of annuities, and the other type is investments. So things like savings account, for example, the example I said before, putting $1,000 into a saving account each year, or superannuation. Now, superannuation is probably the best known example of an annuity. When we work, 9.5% of our income we don't actually see into our pocket. It gets put into our super, and that is consistent. Okay, every pay, 9.5% of it goes into our super, and then that money builds up over time, and hopefully when we retire, it's enough for us to live off. So that's what superannuation is. The technical definition of an annuity as defined in the syllabus I've included here. So this is directly from the syllabus. So an annuity is an investment account with regular equal contributions and interest compounding at the end of the period. So regular equal contributions, that's your regular fixed payment. And it also points out that the interest is compounding at the end of the period. Or alternatively, it's a single sum investment from which regular equal withdrawals are made. Okay, so the key part here is regular equal contributions or regular equal withdrawals are made. So regular equal payments. Okay, now I want to explain that this is different to compound interest. So let's have a think. Compound interest, you put one amount in at the beginning and you watch it grow exponentially. Okay, you gain interest on that one amount. But this is a little bit different. Basically, think of it like this. It might start anywhere. We put in a contribution. Yeah, and then we gain interest on contribution. Then we put in another contribution. We gain interest on that. And then we put in another contribution. We gain interest on that. And we put in another contribution. So these vertical lines you can represent as contributions. So you can see it's a much more complicated looking graph compared to just basic compound interest where it's one payment that you let go. Annuity is multiple regular payments of the same amount. Okay, so the mathematics is more complicated. Okay, so rather than using formulas to work these out, we focus on using either recurrence relations or tables to make our calculations easier. And in this video, we're going to focus on the recurrence relation. So there are two types of annuities to be aware of, the investment kind and like the loan kind, or one where withdrawals have been made. Okay, so the investment kind, when we're adding a fixed amount, you'll see that there's a plus D at the back, and we'll talk about what these letters mean in a second. And for a loan or withdrawal type of annuity, this is the formula that you would use on the right. So just like previous understanding of recurrence relations, whenever you see the n+1 bit, think of that as the next value, and think of v sub n as the current value. Okay, so in particular, so Vn, value of the investment or loan after n payments. V sub n+1 is the value after n+1 payments. It's the next one. Okay. R is the interest rate per compounding period. So just like when you do compound interest questions where you need to change the R to match what it's compounding, you need to do the same thing for these annuity questions. So beware if it's compounded biannually or monthly, etc. And D here is a new letter. It's going to be your regular payment. So if you're making $100 a month, D would be 100. Okay. So that's what D is, the regular payment. Note the above formula are not on the reference sheet, so memorize them. Note these formula assume that the payment is made at the end of each compounding period. And note that V0 is the initial value before any payments have been made. So remember, V0, the naught there refers to starting or initial value. Okay, let's do an example here and we'll see how we go. So I've got $1,000 invested at the end of each year for 4 years at 10% per annum compound interest. Now, the first thing I note, there's a lot of information in the first sentence. So the 1,000 invested at the end of each year. So it's a yearly investment of $1,000. So that's your payment. Your payment is the letter D here. So your payment's going to be 1,000. And now, because it's at the end of each year, everything will be in terms of yearly here. So we got 4 years, we got 10% per annum. You always want to work out D and you always want to work out R for this formula. So 10% per annum will become 0.10 as a decimal. So once you know D and once you know R, you can construct the recurrence relationship very easily, because all that happens is the two bits that have the V with the sub n and the n+1, they stay the same. The only thing that changes is R and D. Okay, by the way, this is a plus D because this is an investment type question. If it was a withdrawing type question or a loan type question, it would have a minus D at the back instead. Okay, so what we're going to do is I'm going to write down the formula. Okay, Vn+1 equals to V sub n 1 plus R plus D. And now I'm going to substitute in. So for R, I'm going to put 0.10 and plus D is plus 1,000. So that there is the answer to that particular question. A lot of people like to simplify this bracket, and for later calculations, it'll be easier to simplify it. So 1 plus 0.1, that'll be just 1.10 or just 1.1. Okay. So that's the answer to A. B. Explain why V0 is 0 for this example. So to explain why V0 is 0, we need to remember that V0 is the initial amount before a payment has been made. Now, nowhere in the question does it say that this account has any starting amount. It's initially starting from 0. Okay. So it doesn't say that the account already had money in it. Okay, so basically there's an assumption here that this account starts off from 0. Okay, so explain why V0 equals 0 for this example. This investment account, and what I'm going to do is I'm going to use the wording up here where it says V0 is the initial value before any payments have been made. This investment account before before any payments have been made, this investment account before any payments have been made has an initial value of $0. So V0 is equal to 0. So basically this question was just getting you to explain that you knew that V0 is the initial amount of the account before any of those regular payments have been made. All right, let's do one more example. So page 3. Alyssa borrows $1,000 at an interest rate 15% per annum compounded monthly. She will repay the loan by making 4 monthly repayments of this amount per month. Okay, so the first thing that it's asking me to do is to make a recurrence relation using the model. So we need to think about what each of these things are. So firstly, I note that everything's compounded monthly, so everything needs to be in terms of monthly. So this rate of 15% per annum, I can write that as 0.15 by dividing by 100, and then we need to make it per month, so we divide it by 12. Okay, so when I do that, I get that R is 0.0125. So I know my R value. The other thing to know is the D value. And the D value is the regular payment. What is the fixed payment that we're paying each time or getting paid each time? So we'll repay the loan 4 monthly payments. The key thing is how much those monthly payments are. 257.85 is D. Okay. So I know R and D, I can substitute into my rule straight away. Now, you might be wondering why I haven't used 4 yet and why I haven't used 1,000 yet. I have a feeling I'll be using them in a later part. All right, let's write down the rule. V sub n plus 1 equals Vn 1 plus R minus D. Note, it's a minus D because it is a loan question. The previous question was an investment question, which was plusing D. Okay, if it's a loan type question or a withdrawal type question, you minus D at the back. All right, so let's substitute in. I'll get the Vn plus 1 equals Vn, and then 1 plus 0.0125 minus 257.85. And that's part A done. If you would like to simplify the bracket, it's very easy to simplify, and that will make your calculations later on easier. Okay, so that's A done. B, use your calculator to determine recursively, remember recursively means one step at a time, the balance of the loan after Alyssa has made each of the 4 payments. Okay, so this is where we're going to start to use some of these facts that we haven't used yet. So, first question is, what's V0? Well, remember, V0 is the amount at the beginning before any payments have been made. Okay, so V0 is the initial value before payments. So before I make any payments, my loan will be $1,000. I owe $1,000. So that tells me that my V0 is going to be $1,000. Okay, and now I want to work out after I've made 4 payments. Well, that's going to be V sub 4. Okay, because this subscript tells me after how many payments. So I need to work my way up from V sub 0 to V sub 4, one step at a time using the rule. Okay, so if this is V sub 0, the next step will be V sub 1. And remember, I'm using the rule. It's going to be the current, which is 1,000. The initial amount is 1,000, times by 1.0125 minus 257.58. Sorry, 85. Put that into your calculator, and you should get $754.65. Okay, so we've had interest happen and we've minused our repayment. So that's at the end of one payment. That's how much is left on my loan after one payment. Now let's go to the second payment. So remember the rule is start with the current value, V sub n. So current value is 754.65. Then we times it by 1.0125. And then we minus our repayment. Okay, put that into your calculator. You get 506.23. Now, it's got many decimal places. I like to write 3 decimal places and put ... We're going to keep it exact. Remember, we only round on the very last line. All right. Now, what I should have mentioned before is remember that when you're putting this in your calculator, the easiest way to do it, I might put calculator over here, is the first step is to put in the V0 equals. So put in 1,000 equals. And then remember, you write in the formula, the right-hand side of the formula into your calculator. And the key thing is you want to replace the V sub n bit, this bit, with the answer key. So if you're doing it on your calculator, you'd go answer times bracket 1.0125. By the way, the brackets aren't necessary, but you can put it in there if you'd like, minus 257.85. And then if you've done 1,000 equals, and then after that done answer times by this minus this, every time you press equals, you'll get the next V value, okay? All right, I'm just showing the full working out because that's what we need to show in the exam. So next, V sub 3. So remember, we take the current value, which is 506.233 ... and I write that ... times by bracket 1.0125 and bracket minus 257.85. Okay, and when you put that in your calculator, you should get 254.711 ... Remember, the easiest way to do it is just keep pressing equals on that calculator after you've set it up. And that's V sub 3, and then V sub 4, which is what we want, 254.711 ... we times by the 1.0125 and minus 257.85. And when we do that in our calculator, you should get 0.0449 ... Okay, which, now that I've got my final value, I'll write it to the nearest cent, which is 4 cents to the nearest cent. Okay, so basically for this particular loan, after we've made 4 payments of 257.85, we've got 4 cents left on the loan. That's what that means. Okay, reminder, the quick way to do it on the calculator, write 1,000 equals, then type in answer times by 1.0125 minus 257.85. Press equals to get V1, equals to get V2, equals to get V3, equals to get V4. Okay. All right, that's part B done. Let's have a look at part C. What is the balance of the loan? Balance of a loan means the amount that is still owed after she's made 2 payments. So after you've made 2 payments, so that means V sub 2, right? Because we make our first payment here, and this is our second payment. So after 2 payments, the balance will be the value of V sub 2. Okay, so after 2 payments, I owe $506.23. So B, balance after 2 payments is going to be $506.23, nearest cent. Okay, that's B done. I think we've got one more question. Oh, sorry, that's C done. We got one more question, part D. Right. Is the loan fully paid out after the 4 payments have been made? Okay, if not, how much to the nearest cent will the last payment have to be to ensure that the loan is fully repaid? All right, well, let's have a look. We've done after 4 payments. After 4 payments, we've still got 0.04 cents left to pay. So we're pretty much there, but we've got 4 more cents to pay. So is the loan fully paid out after 4 payments? The answer is no. The loan is not fully paid out. The loan is not fully paid out. There is still 4 cents left to pay. And the question says, how much will the last payment need to be changed to pay it off in full? So the last payment, every payment's been 257.85. You just need to pay an extra 4 cents to the nearest cent to pay it off full. So $257.89 payment. Last payment, I should say. Does it say last payment or fourth payment? Last payment. $257.89. Last payment needs to be made to fully pay off the loan after 4 payments. Okay. All right, that was a pretty detailed example, and the questions towards the end of the exercise are very similar to this kind. So if you get stuck, go back to the video and watch it again. And if you have any questions, you can always post in Google Classroom. What we want you to do is do exercise 7A. You should have done questions 1 to 5 already. So be working on questions 6 to 13. Question 6 has a table. If you get stuck with that, look back at the example that is in your textbook. Example 2, a few pages before, will help you with how to fill out that table. All the best. I'll see you in the next video.